Okay, let's dive right into this explainer and build a master strategy for the Cambridge Additional Mathematics 0606 exam using what I like to call an architectural blueprint approach. I want you to picture this. The clock is ticking down, tension-building music is practically playing in your head. You've just opened a real Cambridge mathematics past paper. Maybe it's a brutal crossover question, or you're staring down a grueling additional mathematics problem that looks completely alien. Now, let me introduce you to two types of students who are taking this exact same exam. On the left side of the room, we have Alex. Now, Alex completely overloads the page with raw mathematical facts and formulas, literally dumping every single piece of knowledge they have onto the paper, but providing absolutely no structured analysis. It is a chaotic mess. On the right side, we have Sam. Sam rushes through the paper, completely missing the specific command word requirements, frantically trying to find a final number while completely ignoring the mathematical journey required to actually get there. If you were to look at their answers side by side right now, they would be absolutely covered in red pen marks from the examiner. Why? Because they are both trying to build a complex house without a blueprint, and their mathematical structures are just collapsing under the pressure. Well, today, we are going to fix that. We are going to design your answer like a master architect, where every single paragraph of your working out is a structural masterpiece. Now look at this number on the screen. What is really interesting and honestly a bit mind-blowing about this is that questions utilizing the quadratic formula from the given list account for a massive 15% of your total examination marks in the Cambridge 0606 syllabus. I really want you to stop and think about what that actually means for your final grade. 15%. That is not just some passing minor detail. That is literally the difference between two entire grade boundaries. We are talking about the difference between a solid A and a C. It is an absolute goldmine if you know how to extract those marks, but it's a devastating grade-sinking trap if you don't. Think about it. The quadratic formula is literally handed to you in the list of formulas at the front of the paper. You don't even have to memorize it. Yet, year after year, thousands of students completely lose these marks. You might be wondering, why on earth does that happen? Well, it's because they think the marks are awarded for just magically writing down the final numbers, but they aren't. They are awarded for how you deploy that formula within complex, unfamiliar contexts. You are essentially being handed a high-powered industrial tool. The examiner wants to see if you actually know how to plug it in, calibrate it, and use it safely to build something, rather than just recklessly throwing it at the wall and hoping it sticks. So to secure those critical marks, we're going to follow this exact four-part agenda today. Number 1, the assessment blueprint. Number 2, the method mark strategy. Number 3, the building process. And finally, number 4, the inspector's report. Let's start with section 1, the assessment blueprint, and really look at the core principles of how examiners assess your logical and structured reasoning. Okay, so the theoretical architecture of this exam targets these 3 distinct cognitive domains, and they strictly prioritize analytical depth over superficial breadth. You have knowledge and understanding, which is honestly just remembering that a formula exists. Then you have application, which is simply plugging the numbers in. But analysis, now that is the top tier. That is where the A-star students live. To conquer this domain, top students use a secret weapon, the PEAL framework. That stands for point, evidence, explanation, link. Now, how does this apply to math? Well, your point is stating the mathematical principle you're using. Your evidence is extracting the specific coefficients from the question. Your explanation is showing your clear, step-by-step algebraic manipulation. And your link is connecting your final roots back to the physical context of the problem. When you face a complex question, you aren't just solving an equation, you are translating reality into mathematics, and then translating the mathematics back into reality. Now, before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE, to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's keep building. So the crucial takeaway here is that top-performing students demonstrate total mastery by connecting fundamental principles and transferring them to completely unfamiliar contexts. This right here is exactly where Alex, our student from earlier who just overloads facts, goes terribly wrong. You see, Alex treats every single math topic as an isolated island. But guess what? Cambridge examiners absolutely love cross-topic connections. They will give you a seemingly standard geometry problem involving a tangent to a curve. But then that requires calculus to actually find the gradient, which then requires setting up an equation that suddenly turns into a quadratic, which you then have to solve using the formula from your list. It's like a giant puzzle. If you cannot see the invisible bridges connecting geometry, calculus, and algebra, you are going to be left stranded on that island. The students who score the absolute highest marks, they don't see separate topics. They see the entire syllabus as one massive, beautifully interconnected architectural blueprint. All right, let's move right along to section 2, the method mark strategy. We are going to explore what is undoubtedly the most important tool in your entire exam survival kit. Now, I really want you to let this definition sink in. It highlights that the exam isn't just about finding the right number. It's about proving you have a professional, systematic procedural framework. Imagine all those red pen marks on Alex and Sam's papers suddenly, magically transforming into green check marks. That actually happens when you stop obsessing over the final destination and start respecting the procedural journey. Listen to this. Method marks are awarded for the process, regardless of whether your final answer is perfectly accurate. You could literally press the wrong button on your calculator at the very last possible second, get the final answer completely wrong, and still walk away with 4 out of 5 marks for that question. How insane is that? When you substitute the values of A, B, and C into the quadratic formula, and you actually write that substitution down explicitly on the paper, you have just bought yourself an incredible insurance policy. If you make a silly arithmetic slip in the very next line, the examiner still sees that correct substitution and awards the method mark. But if you try to be a hero, do it all in your head, and write down the wrong final answer, you get a 0. It is as simple as that. Let's move to Section 3, the building process, and see how all of this theory actually builds into technical execution when you're staring down a really complex past paper problem. Whenever you tackle these specific, multi-layered problems, you absolutely must follow this exact 5-step procedural framework to extract your data from texts and tables and draw evidence-based conclusions. Let's actually do this right now. Let's imagine applying this to a complex word problem. Step 1, deconstruct. You scan the text and identify the command word is determine the time when the object hits the ground. Step 2, extract. You pull out the initial velocity and height from the word soup. Those are your specific coefficients. Step 3, select. You realize this path is a parabolic arc, so you select the quadratic formula as your analytical framework. Step 4, execute. You write out the formula crystal clearly, substituting your data, which creates your point and evidence from our Peel framework we talked about earlier. Step 5, present. You solve it, getting 2 different times. You then present the correct positive time with the right terminology and units, successfully completing the link phase of your answer. Boom, full marks. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, jumping back in. You can easily encode these concepts into your brain using a visual story method, treating your data as raw building materials and your mathematical process as the actual construction phase. Let's play a quick game of Find the Flaw. Listen carefully to this sequence of working from a real past paper. A student extracts the numbers 3, -5, and 2. Then they write down x equals 5 plus or minus the square root of 25 minus 24, all divided by 6. Next line, they write x equals 1 and x equals 0.66. Now, where did they lose marks? Did you spot it? They lost method marks because they didn't explicitly show the initial substitution of the -5 being squared or the 4 times 3 times 2. They jumped straight to the computed values of 25 and 24. Sure, they got the right answer this time, but if they had made even a tiny calculation mistake, they would have 0 method marks because the examiner cannot see their materials. They skipped pouring the foundation of their building, and examiners hate that. At the absolute highest level, this problem-solving cycle demands that you check your work for reasonableness and back up every single mathematical step with hard evidence. Let's do a 30-second speed writing challenge right now, just mentally in your head. Imagine you need to draft a perfect Peel paragraph for rejecting a negative root. How would you do it? Well, first, you would state that solving the quadratic yields t equals 4 and t equals -2, right? That is your point in your evidence. Then you explain that t represents the time in seconds elapsed since the object's launch. That is your explanation. Therefore, you must reject t equals -2 because time literally cannot be negative in this physical context, leaving t equals 4 seconds as the only valid solution. And that right there is your link. That is evaluative thinking in action. You are questioning assumptions, you are considering the physical perspective of the problem, and you are rigorously justifying your decisions. Finally, let's dive into Section 4, the inspector's report straight from the Cambridge principal examiners to see exactly how students lose marks on the big day. This report brilliantly illustrates the top 3 absolute worst mistakes students make: context mismatch, sloppy presentation, and generic responses that fail to address the specific scenario. Let's break these down. First up, using the wrong approach. The absolute classic trap here is trying desperately to factorize a quadratic equation when the question secretly requires the formula because the roots are irrational. Let me give you a massive hint. If the question says give your answer to 2 decimal places, that is a giant flashing neon sign from the examiner screaming that this equation does not factorize cleanly. Use the formula.
Second warning, forgetting format. So many students forget to include the plus-minus sign when taking a square root, immediately losing one of the valid roots entirely. It's such a painful way to lose a mark. Third, generic responses. Let's say the question asks for the coordinate points where a curve intersects a line. If you do all the math but only provide the x values from your quadratic formula, you haven't answered the specific context. You built the walls of the house, but you completely forgot the roof. You need the y values too.
The ultimate examiner alert is this stark side-by-side contrast. On the left hand, the master architect takes deliberate, calculated moves. Their work perfectly aligns with the rules that absolutely guarantee top marks, decoding the command word, strictly applying that Peel framework, and managing their time perfectly because they know their beautiful, highly structured working has already secured the vast majority of the method marks. But on the right hand, the student who fails to show working just descends into total chaos. Failing to show your working guarantees lost marks, whereas systematically showing your process acts as a vital, impenetrable safety net. Don't ever let your working look like the chaos on the right. Now listen closely. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, AC Exams, at @ACExams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @ACExams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. AC Exams, your Cambridge success starts here. As you sit down to practice your past papers this week, I want you to ask yourself this one final provocative question. It's something that should fundamentally change how you view this exam. Remember that mastering the blueprint is the true key to acing it. If the quadratic formula is already perfectly handed to you in the list of formulas, are you failing the math or are you failing the method? Think about it. Good luck with your studying.